console.log count is greater than 4. And I can do kind of the opposite as well, else if count is less than 4. So console.log count is less than 4. Guess I changed modalities there. And then at that point, this will never happen ever, because one of these three conditions would occur. We'd never get to this final else statement, right? It would never happen. So let's go and save our work here and see this run. Count is less than 4 because it's 3. Okay. So that's the general structure of the if statement. It allows us to evaluate one or more expressions. If that expression returns a true, then we execute the code in the code block associated with that expression. We can create optional else or else if statements to continue to evaluate other expressions. Usually you'll want to make related ones, but you don't necessarily have to, although that may not make a whole lot of sense, depending on your business rules. And then we can finally use a catch-all in case none of the previous else if statements are correct, and kind of capture that. So let's go ahead and comment that out. That's our first structure. We'll use the if statement a lot. The next type of statement is a switch. It's a little bit more tricky to use. Let's start off with just typing out the switch keyword and what we want to evaluate. And so what we'll do is actually evaluate whatever's in this expression against a number of cases. So I might, for example, let hero equal Superman. And then depending on the hero, I might want to print out the superpowers that that particular hero has. So based on the hero, if that hero, so if the case is Superman, I would say, well, that hero has console.log super strength. May also have X-ray vision. All right, let's add another case here and say case Batman. And notice that kind of the format of this is to use the case keyword inside of this block that belongs to the switch. The case keyword, the value we want to compare our case against, and then a semicolon, and everything beneath that will become part of the body of that case that gets executed. So in this case, we'll say, what are Batman's superpowers? He has intelligence, and he has fighting skills. All right, and then we can also then say, well, the default for that hero is that they're a member of the JLA. Now watch how this works. It works a little bit different than the if and else if. So let's go ahead and say what we have and then rerun this. All right, so in this case, it was Superman. And notice that we matched the case Superman because it prints out super strength and X-ray vision. But then everything else inside of all additional cases, including the default case, will be true as well. So he also is intelligent, he has fighting skills, and he's a member of the JLA. Now if we were to change this to, let's say, Batman, and we were to run the application, you'll notice that it skips over all of the console log statements that describe Superman's superpowers, and they come in, however, here at Batman. So console log intelligence and fighting skills, and he's also a member of JLA. Now we could try somebody like a Green Arrow, not particularly one of my favorite heroes. And he's just a member of the JLA. All right, now if we don't want that flow through style, what we can do is actually use a break statement in here. So let's go back through this now and see what happens whenever we break out of a given case. So back to Superman. And now when we run it, we only see that he has super strength and X-ray vision. Batman has intelligent fighting skills, and then Green Arrow is just a member of the JLA. Okay. All right, one other quick tip here is that whenever you're evaluating strings, there's a possibility, like for example, Batman. What if we had capital B in Batman, all right, and then we run the application and you see he's a member of the JLA. Why didn't it catch the case Batman? Because capital B Batman is not the same as lowercase b Batman in that string. Now, what we can do to circumvent that, whenever we're working with strings and we want to do some comparison with them, we can use the toLowercase method of our strings. So strings have a built-in method called toLowercase, and that will take whatever that input is and it will make sure that all the letters are lowercase so that we're really comparing apples to apples instead of apples to oranges. So now when we rerun the application, we get what we would expect with Batman. Okay? All right, so let me comment this out. We've looked at the if statement, we've looked at the switch, and then the third one we're going to look at is the ternary operator. And this is useful whenever I want to just do a quick inline evaluation of some expression and then return back a value, a string, number, Boolean, whatever, probably just a string or a number, back, depending on whether that expression evaluates a true or false. Very small, short, concise, inline statement. So I'm going to create two variables. I'm going to do something a little bit different though. The first variable I'll create like you would normally expect, but instead of ending that line and moving to the next one, I'm going to do another variable creation, variable declaration, and assignment right here in the same line. So I'm going to create another variable called b and initialize its value to the string 1. All right. So just a slightly different technique. You might see that online. Moving on. So we're going to create another variable called result, and we'll set that equal to some evaluation of an expression. Does A equal B? So two equal signs that are next to each other is the equality operator. This is a check for equality to say, does A equal B? And if that is true, then what we'll do is return the word equal as a string. But if it's not true, notice the colon that separates the true from the false, we'll return the word unequal. So the ternary operator has kind of got several parts here. There's an expression, there's a question mark that has true or false ramifications, and we'll just do a console.log the result, like so. So now let's go ahead and run that, and these are equal. Great. We could also do this in line. So let me just take this part right here and do that instead. And you can see how we can basically perform that same check without having to create a new variable to hold the result. All right, so it's a nice inline way of running a quick check and then returning back a string, one string or another string. Now, let me just go back for a second here. Or actually, let's do this. And then we'll do console.log result. Okay. Let me comment this one out. I want to keep it around for you in case you want to reference that in the future. We used two equal signs, but there's another type of equality that we can check for, and that's strict equality. And this will check to make sure that these two values are equal, but then in addition to that, it will not coerce, for example, the number 1 and the string 1. It'll say, are these absolutely equal? even with the same data types. All right. And so in this particular case, we should expect a different result. These are unequal. They are not the same. All right. So these are the same because I'm looking for equality. But if I'm looking at strict equality and I'm not allowing JavaScript to coerce the integer into a string and then check for equality, then I have to say, no, these are not the same because one is a number and one's a string. All right. All right. So let me comment that out and let's do one more check here. In this case, I'm going to use a different operator, the not equal to operator. So I'll just use the word not unequal and not equal and not unequal. All right. Which would be the same as saying equal. All right. So now let's see and run that. And this produces a false. So this would be returned back and then displayed on screen. But then we can also do strict inequality by adding another equal sign to that operator. And these are not equal again because it is true that A is not strictly equal to B because they're different data types. All right, hopefully that makes sense. All right, so let's go ahead and stop there. And hopefully all of this ternary operator business and equality and strict equality makes sense, and let's move on. You're doing great. We'll see you in the next video. Thanks. In this video, we'll talk about iteration statements. Iterations allow us to loop through a body of code, a block of code, a number of times until a certain condition is met. And there's a couple of different types of iteration statements. We'll look at 2 in this lesson, and we'll even look at them in relationship to arrays, something I promised several lessons ago. So let's start off by creating a new file and call it iterations.js. And inside of here, we'll create our first for loop. So for, and then there are 3 parts inside of the opening and closing parentheses. First of all, we'll let I equals 0, or we can actually just shorthand this and not even use the keyword let. And here I less than 10, I plus plus. And so this is going to take some explanation, but let's just get this working first, and then I'll come back and I'll talk about it. And we'll just print out the value of I. All right. What do you think is going to happen here? If I didn't tell you anything about how the for loop actually works, what do you think will be printed to screen when we execute our script? Let's find out. So let's go here and type in node iterations. All right. So we get several, it looks like 10 different values printed to screen, each on a separate line, 0 through 9. And then our application exits. All right, so let's talk about this. It's a shorthand syntax, and there's 3 parts as separated by these 2 semicolons inside of this this evaluation header for the for. First of all, we declare a variable. In this case, I've declared I. That's why we use the let, but then I said, well, we really don't need it. Let's keep it short. So we're declaring it, and then we're going to initialize its value to 0. In the second step, we're going to say continue running this for loop as long as this condition is true. So as long as I is less than 10, continue running the body of this for loop as defined with this set of curly braces here. And then finally, after you've run an iteration, increment the value of I by 1. All right. And here we're going to then print out the value. And that's why we start at the value of 0. And then we work our way all the way through this 10 times. On the 10th time, I gets incremented to 10. This check is performed. It's false. And then we exit out of the program. All right. Now, let's do something a little bit more interesting like I suggested before. Let me comment this out. Here, let's go let A equal to, and this should look familiar, 4, 8, 15, 16, 23, and 42. Whoops, I guess I forgot equal sign there. And now what we'll do is for I equals 0, I is less than a dot length I plus plus. Inside the body of this, we'll do console.log a, and what element? Well, we'll use I, because I will start off with the value of 0, and it will continue until we get to the length property, which is not 0 based. Once we get to, for example, the 0, 1, 2, 3, 4, 5, so length will be 6 elements. So once I is 6, it's no longer true that I is less than the length of this array, and we'll exit out. So let's go ahead and save this and then run. And we can see we get all of our values printed out to screen. So that's the proper way to iterate through, or one way I should say, to iterate through an array. Now, one thing about Visual Studio Code that I really love is that they have this notion of code snippets. So if you ever forget this syntax, and it can be a little daunting at first, there's a way to remember it perfectly every time, and that is to let the code snippets build it for you. So I type in the for keyword, IntelliSense pops up with a little window under it, and I'll use the arrow keys to go to the for loop JavaScript. All right, there's a couple of fors, but the one that we want has this little box with dots underneath of it. That tells me that this is a code snippet. I hit enter on my keyboard, and now I get the basic structure of my for loop already created for the purpose of an array. Now notice that every word index is highlighted, and I can change that every instance of that by just using a letter. Like I'm going to change this to the letter B instead of index, and notice that it changed it everywhere. And then I'm going to hit the enter key on my keyboard, which was the wrong move. Then I'm going to hit the tab key on my keyboard, and I can change the name of the array now. Everywhere the word array is used, I can swap that out with the letter A, for example. I'll use the tab key one more time. Here it puts me to another replaceable area for the element, and here I'll use C. I'll use tab one more time, and then it kind of exits me out of that snippet replacement structure, and now I can continue on and type like console.log, and we'll just print out C. Okay. So let's grab A from our previous example, and then we get the same results as we got before, but this time we didn't have to memorize exactly how to use for. The code snippet walked us through and allowed us to replace the names of the various replaceable areas, like the name of the counter, the name of the array, and the name of the given element C that we extract out of our array. Okay, so let's comment that out. That's for, and now let's take a look at the while loop. So we'll talk about the difference between these. It may not be obvious at first, but essentially we'll do this. All right, so take a look at this. Knowing what you know about loops, what do you think is going to happen here? Well, we start off with 1, and we're going to continue to execute this loop until this condition is false. So the very first time we run it, 1 is indeed less than 10. So we'll continue to run the body, the block that's associated with our while statement, and we'll print out the value of x and then increment its value by 1. We'll continue to do this until we increment the value of x and it becomes 10, at which point this is no longer true, it becomes false, and then we'll break out and continue on. So let's go ahead and see what the value is that we get. So we get 1 through 9, that's expected, and once we hit 10, we break out. Great. All right, so what's the difference between the while statement and this first for loop that we did here at the very top? Well, the difference is that the for loop, first of all, has a lot of infrastructure that we have to build, these 3 pieces. And it uses a series of indexes that represent the number of iterations that will move through this block of code. Now, the while statement is a little bit different. Anything can be used to drive the iterations. As long as this statement continues to be true, we'll continue to execute this block of code. And so we control the number of iterations in the body. In this case, here I do the x++. Now, we don't have to use counters. We could use anything, any kind of business logic, like we may want to read to the end of a file, and once we hit the end of the file, it makes sense to continue to read each line of the file. Then we would want to break out. So the while is a little bit more flexible in so much that we can build a business logic for how many times we're going to iterate in the body of the while statement. Whereas with the for, we're pretty much limited to the number of times we want to run this being the number of times that we've kind of preset it up here in this top section outside the body itself. Okay. Now there's also one last thing we can talk about, and that's a way in both the for and the while we can kind of circumvent this check right here, and we may want to do a check like this. So if x is equal to 7, then we'll call the break statement. All right, so learning what we've learned about the if statement, it probably should look more like that, right? So first of all, let's make sure it works. All right, in this case, we got 1, 2, 3, 4, 5, 6. Once we reach the 7, we circumvent this check and just say, hey, I want to break out of this. All right, so we can use that always to break out, just like we broke out of the switch when we wanted to not let it flow through additional cases. Now, the one thing I will say, if you notice how I typed this to begin with, let's retype that. So hold on, let me comment this out so that you can see it in the code if you want to download my code. But we could also do it a little bit more shorter and in line. Since I only have one statement that I want to make right after the if statement, I can do it on the same line, and I don't need to surround it with a code block. A code block indicates that there's usually more than one line of code. In this case, there's just one line of code. I could put it on the separate line and use some indentation like that, or I can just keep it all on the same line since it's so short. But that might improve readability, or I might decide that this is a more readable form. That's kind of up to me, and if I'm working on with a team of software developers, I might want to get and kind of do it the way that they do it. But stylistic for me, this is so short, I can read it all in one shot. If x is 7, then break out of it. It looks good. It's very readable. I'll be able to understand what I'm doing later on. It doesn't take up and move the code down. So I like that format if I just need to create one statement right after my if. So sometimes it makes sense to split things on separate lines. Sometimes it makes sense to keep two different statements on the same line. Again, I think it kind of is a stylistic choice that you'll have to make for yourself at some point. All right, so that is iteration statements. We looked at two different kinds, and we looked at how code snippets can be used to help us remember the format. Now, I believe the while has, in fact, I believe most of the things that we've looked at has some code snippets available to them. Like if I find it here in IntelliSense, you hit enter on the keyboard, but there's not as much to it there. I mean, while with the condition, I can change this to x is less than 10, right? It's not so much for me to type that out, but the for makes a little bit more sense because there's so many parts to it and replaceable parts of that. Okay, so let's continue on in the next video. We'll see you there. Thanks. It seems like quite a while ago we talked about variables, but now that we're working with blocks of code inside of blocks of code like we had here in lines number 23 and then 29 through 31, we need to talk about variable scope. And when I use the term scope, I mean variables are a little bit like people, in so much that variables have a lifespan. They're born, they do work, and then they die, and they're removed from computer's memory when they go out of scope. And we'll see an example of that in just a moment. But they're also like people in so much that they have a citizenship, I guess you can say. In other words, depending on where they were born, they can work inside of some code blocks, but not other code blocks. And so the remainder of this video, we're going to look at lifetime and availability, or citizenship, I guess you can say, inside of the rest of your application. So let me create a new file, and we're going to call this Scope Basics. And there will be more to say about scope as we move forward and learn more about functions and so on in just a little while here. But let's start and create our first example here. So let a equals first. Then I'm going to create a function called scope test. And inside here, I'll just do a console.log. And the first thing I want to see is if I declare a variable out here, outside of my function, can I reference it inside of my function? And so to find out, let's just call scope test and see what we get. So here we're going to type node scope basics, and we can in fact view the value of a variable that was declared outside of the scope of a function. We can view it inside of the scope of that function. All right. So the next thing that I want to do is to say, hey, let's create a variable here. Now, if I create a variable inside of a function scope, can I view it out here outside of the function scope? So console.log b. And let's see. And so no, not only can I not see it, but my application actually blows up. And you can see the little caret here is right underneath the B, and it says B is not defined. So in other words, you can kind of think of it again in terms of the lifespan. We created a function and we created a variable inside of that function. That variable lives as long as that function is running, but after the function, after that code block has completed executing, then B is removed from the computer's memory and essentially thrown away. Therefore, we cannot reference that variable outside of the function because it no longer lives, it's dead. All right, so we're going to have to comment that out, and we can go ahead and comment this out as well. Now, let's do one more thing here. Let's say if A, and we'll just do something silly here. If it's not equal to an empty string, so just two single quote marks next to each other, so then can we still see the value of A even inside this innermost block of code that we defined with an if statement? If we can, we should see then it printed here a second time the value first. So let's save what we have. Let's run this again. And so we see first. The first time it's printed out and the second time that is printed out. All right, so yes, if something is declared in an outside scope, it is visible, or it has citizenship in every inner scope from that point on. But here, once again, if we were to create a variable third and then try to reference it outside of the code block in which it was defined, like so, will this work? What do you think? We're going to get that same kind of error before. We get the little arrow pointing to the C, and it says that C is not defined. The variable C was defined inside of this code block, and once we executed that code block and got to the end of it, then C was removed from the computer's memory. It's no longer available to us. In a sense, dies, and it's no longer available. Okay? Now, let's just do one last thing here just to kind of understand that we are, in fact, able to work with the variable that was defined in the outermost scope. Can we still work with it, do it, use it, and change its value? So I'm going to change this to changed. And then I'm going to reference it here, console.log A. And so now let's run our application one more time. All right, so the first time that it's run, this first console.log, it will be the value first, but then we change the value and we log it again, and that's where the second changed